Hello everyone. Today's topic is Zener Diode voltage regulator. Just like in the PN junction diode we have studied, we will study now Zener Diode, which is working uh, basically in breakdown region. Okay, its breakdown voltage is 6.8 volt, which is available in our laboratory. Okay, let's see the circuit diagram. So this is just like in the diode PN junction diode we have studied. We require a DC source, then we don't need a rheostat. We will directly connect this series 1 kilo ohm resistance, and then this 1 ampere ammeter. We will connect a multimeter as a ammeter, and then in series we connect Zener diode. We have to study in the reverse bias because breakdown occur in the reverse bias, and then in parallel we connect a multimeter as a voltmeter. Okay, so this is the circuit diagram, and now we will implement this in the Tinkercad. So first thing we require is breadboard. Let's type breadboard. We generally use 840 pin breadboard. Just drag and drop here. Here is our 840 pin breadboard. Then we require a DC source. Let's bring a DC source. It is available in all section. Go to the power section. Here it is power supply. It is available. You can see. Okay. Then you require a resistor, which is available in the basic general, and you require a Zener diode. It is Zener diode. Drag and drop here. Now we have to connect all these things. Okay. We also require two multimeters. Let's see, two multimeters. One as a meter, one as voltmeter. Just drag and drop here. Okay. Now I think we have everything. So let's connect the circuit. First, make a ground. Connect all ground. If we connect the ground in this line, you can see all are salted. So this entire line will be grounded now. Okay. So this connect this because entire circuit should have common ground. Okay. Now make it black as in the laboratory. It is available in the black color. Okay. Now we need a resistor. We have to rotate it. Okay. Here it is a resistor, and in series we have to connect Zener diode. In the reverse bias is the silver strip. You can see the silver strip is N side and this black strip is P side. This is anode and this is the cathode. So first we will study in the reverse bias region. Let's connect here, and in between them we will connect ammeter in series. Okay. We have to connect ammeter in series. We have to delete this. Make it red. and this negative side make it black. Now there is a resistor, then there is a ammeter, in series there is a Zener diode, resistor, then in series ammeter, then in series Zener diode, and in parallel of the Zener diode we have to connect this voltmeter. Okay, so let's connect this voltmeter in parallel with Zener diode. Okay, make it red and make it black. This is grounded. Now this is also grounded. Now we have to connect this DC source to the resistor. Okay, now let's first check the circuit. We have a DC source. In series of the DC source there is a resistor, then in series there is an ammeter, then in series there is a Zener diode N side and then P side. We have connected in parallel, there is one voltmeter. Okay, so just double click on this. We have to use this one is a MP ammeter, and we have to use as a voltmeter, which is already by default. Okay, so let's our connection is completed. Let's run this simulation. Start this simulation. Okay, we have to reduce this voltage from 0 volt. There is a knob. Okay, you can increase or decrease the voltage here by clicking here. Okay, so let's start the simulation. Reduce the voltage to the 0 volt. Now start increasing this voltage by rotating the knob in clockwise direction. You can see the voltage across the Zener diode, and in the ammeter the current through this Zener diode. Okay, 2.2, 3.2 volt, 3.8 volt, 4.4 volt, no current. Okay, 4.4 no current, 5.6 very small current, 442 microampere, 5.6 volt, 5.21 991 microampere, 5.29 volts, 2.11 milliampere. Now you can increase the voltage. This DC voltage keep on increasing, but the voltage across this Zener diode is almost saturated, and the current can increase. You can note down this voltage and current rating: 5.46, 4.74 milliampere, then 5.69 volt, 8.71 milliampere, 5.8, 10.6. You can see the voltage, a very small voltage change, but current can change a lot. Okay, so this is the now the Zener diode is in breakdown region. Voltage is saturated, but current can increase. So this is the function of Zener diode. This is the this function is in the reverse bias. So let's study also in forward bias. This is the reverse bias characteristic. So you have to put negative sign. Okay, you have to put negative sign in all voltage rating. Okay, so you have to make this kind of table, experimental table. You have to note down the voltage in volt and current in milliampere. When we study reverse bias, just put negative sign. Okay, in the reverse bias, put negative sign in the voltage, and then draw this table. Okay. Now study in the forward bias. We have to just rotate this Zener diode. Let's stop this simulation. Now rotate this Zener diode. Now it is connected in PN. N means this is in forward bias characteristic. Okay. Now we have to study the forward bias characteristic. So let's run this simulation. Start with 0 volt. 0 volt, there is no current. Must rotate this knob in clockwise direction. $200 millivolt, there is no current. Almost 516 millivolt, and then current is 484 microampere. So the behavior is just like ideal PN junction diode, or a practical PN junction diode. Okay, so in this way we can study the forward characteristic of Zener diode, and we can observe the forward characteristic of the Zener diode is just like the PN junction diode, and the reverse bias characteristics shows that there is a breakdown voltage where sudden current will increase. Sudden current can increase. So because this voltage saturate and current can increase, so that's why it is used in the voltage regulation. Hence Zener diode is known as voltage regulator. Okay, now you can change this voltage and current, note down this voltage and current, make this kind of table, then draw either in MATLAB, Scilab, or you can also use Desmos to draw this graph. Okay, thank you.